Question 3 is also integration by substitution. Using the substitution u is equal to e to the x, find this integral. So if we let u equals e to the x, then du by dx is going to be, well, e to the x, which is of course just u. So we'll keep this in mind. Of course that also means dx by du is going to be 1 over u. Okay, so what can we say about the integral of 1 over e to the x plus 2e to the minus x dx? Well, that's going to now be the integral of 1 over u plus 2 over u dx by du du. So that's going to be the integral of 1 over u squared plus 2 over u times 1 over u. So these two will cancel out, du. And then this we recognize again as u squared plus a constant squared. In this case it's root 2 squared. And that is our tangent inverse. So this is just going to be 1 over root 2 tangent inverse of u over root 2 plus c. Now importantly, we aren't supposed to leave our expression in terms of u. We should convert it back to what we were given at the start, which is x. So this will be 1 over root 2 tangent inverse of e to the x over root 2 plus c, and that's our final answer. Alright, very last question. By expressing 4x plus 5 in the form a, 2 minus 2x plus b, do this. Okay, so what do we recognize? Well, the integral of from 0 to 1 of 4x minus 5 over the square root of 3 plus 2x minus x squared, we can split it up as minus 2 minus 2x minus 1, whole thing over square root of 3 plus 2x minus x squared dx. And then that splits up again, so this is minus 2 times the square root. Actually, sorry, I might just start further to the left if you guys don't mind. So that splits up. This is minus 2 times the integral of 2 minus 2x over the square root of 3 plus 2x minus x squared. And the reason we want to write it like this is now the top line is the derivative of what's under the square root sign. And then this is minus the integral of 1 over the square root of 3 plus 2x minus x squared dx. And this one we're going to have to use our sine and cosine integration to simplify that. Okay, so this is nice and easy. That's going to be minus 2, stays at the front. Then we just take this thing on the inside, 3 plus 2x minus x squared, increase its power by 1, divide through by the new power. And that happens, of course, between, sorry, I left it out on this step, but these are all happening between 0 and 1. Minus, this is the integral from 0 to 1 of 1 over the square root of, and if we complete the square we get 4 minus x minus 1 squared dx. And again we've got a formula for this general form. So this is minus 4, 3 plus 2x minus x squared, the power of half, 0, 1, minus sine inverse, and then 4 is 2 squared, so this is x minus 1 over 2. So x minus 1 from this term, 2 from 2 squared here. And again that's between 0 and 1. So when we actually start calculating this, what do we find? We get 4 root 3 minus 8 minus, when x is 1 we get, so that's the first bracket, when x is 1 we get 0 minus, when x is 0, get negative 1 over 2, so that's positive, sorry, no, I might just write it minus, yikes, what happened there? minus negative pi upon 6. And that, once simplified, becomes 24 root 3 minus 48 minus pi over 6. So to answer the question where a and b are constants to be found, therefore a is equal to 24 and b is equal to negative 48. And we're done.